Hello there, my name is Grigory Volkov. I'm from Saint-Petersburg State University, Russia, and I would like to present the results of our joint research with my colleague Alexey Evstifeev about effect of magnesium on dynamic properties of aluminium-magnesium alloys. This is the outline of our report. First of all, I would like to say about our experimental equipment that we have and our test methods. Then a few words about incubation time criterion and how to analyze dynamic properties in accordance of this approach. The third point is about Saint-Petersburg sump method. This is a relatively new approach, and it allows us to estimate true value of material parameters under the lack of experimental data. And finally, results and conclusions. This slide shows how we used to analyze dynamic strength properties of materials according to incubation time theory. This is a general form of the incubation time criterion, where sigma is a loading function, sigma c static strength of material, and tau is incubation time. Alpha dimensionless coefficient, and it's often equals to 1. Tau is also strength parameters, which characterizes material strength in dynamics. Usually we have few experimental points. For example, it could be obtained by Koski method using Hopkinson split bars. And then we find a certain value of tau by adjusting theoretical curve to these data points. The main disadvantage of this method is that we have no information about confidence of this result. A small number of data points doesn't allow us to provide statistical analysis. Here you can see electrical discharge machine that we use to producing our non-standard specimens and some custom tools for other experimental setup. It has quite a good rate of performance, up to 1-2 micrometers. The present research was provided on follow setup Instron CEAST 9350. It has follow operation parameters, and the main restriction is a relatively weak force sensor, is only 2.2 kilonewtons. So we decided to design a small specimen and a special holder to be implemented into standard Droptower equipment. So we tested a few different aluminum alloys with different percentage of magnesium quantity. Then we have the follow plot, and it is very difficult to conclude whether one alloy has better dynamic properties than another has or not. Static strength of material can be measured directly, but what is about dynamic strength? We haven't a similar interval for dynamic strength, and so our goal is to develop a standard procedure to estimate value of incubation time and to obtain the similar interval for it. Our assumption that the load function is close to linear, and we can express it by follow statement. By substituting this statement into incubation time criterion, we can have this equation, and the solution of this equation gives us a value of fracture time. We can substitute this fracture time value to the first statement, and finally we can have strain rate dependency of strength sigma star, and there is an analytical solution in case of alpha equals to 1. So we call this function phi, and our further goal is to estimate this value of parameter tau by fitting this function phi to experimental points. We consider experimental data points as a result of observation, and this critical stress sigma star is equal a prediction by our criterion plus random noise Vi. And now we wanted to obtain the optimal value of tau. We want to estimate the true value of tau by results of this observation. And as I said before, the number of observation n is usually is very small because dynamic experiments are very difficult. So we suggested only one restriction to this random noise. Y are random variables with unknown symmetrical distribution. So there is no another restriction about random noise. Okay, for this purpose we used Saint-Petersburg sums approach. It was suggested by Campe and Ware in 2015, and this is a randomized approach that permit us to estimate goal parameter value under a weak assumption about random noises. First of all, we should set values of parameters m and q, and it should be chosen so that the true value of the rate of confidence is equal follows. And then we should generate random signs beta, and then evaluate the follow Saint-Petersburg sums. And then we should apply SPS Indicator Procedure to check whether confidence interval include current value of tau or not. So briefly, SPS indicator procedure is following. For a given tau, we should compute prediction of prediction errors delta I for every data point. Then we should evaluate follow intact sum with the ones and Saint-Petersburg sums. Then we should order modulus of these sums from smallest to biggest one and compute the rank of tau, where the rank is number of place sum h0 in this ordering. If the rank less or equal m minus q, the procedure return 1. It means that this value of tau is satisfied and it includes it is included in our goal interval. Otherwise it returns 0. This slide shows the results of our simulation. We choose the value of parameters m and q 105. So our confidence probability is 95%, and we estimated we obtained intervals for incubation time. So this table shows that static strength of material increases due to increasing of percentage magnum in total amount of alloy. But dynamic properties, which is characterized by incubation time, is different. And we can see that generally it became slower, but in case of IMG 3 and IMG 4.5, we can see that dynamic properties of the IMG 4.5 is greater than in average is greater than dynamic properties of IMG 3. So it is a very interesting fact. Finally, we can conclude that our small size custom specimens allows us to test material dynamic strengths in Instron CEAST Droptower. We tested different aluminum magnum alloys, and the experimental data demonstrates strain rate sensitivity of these materials. So also we can conclude that increasing of magnum quantity generally leads to higher static strains. But in dynamics, the resistance of these alloys is different, and yes, in generally is getting worse. But in case of alloy AMG 4.5, we could see that their dynamic properties is better than AMG 3 alloy. And also Saint-Petersburg sums shows that it could be applied, it could be implemented to incubation time theory to estimate a value of the material incubation time, and we obtained relatively narrow intervals contains true value of the incubation time with the high rate of confidence is about 95%. For your attention.